last video on probability, I just wanted to look at something that's a little bit different, just to show that hopefully once you've seen all these videos, if you get a question which is phrased slightly differently, or you have to think outside the box a little bit, you've got all the stuff, you're well equipped to deal with it, and you can think logically about it. You can always draw a tree diagram if you want to help you visualize what's going on. You can always draw a little picture if you want to help you visualize what's going on, but hopefully you'll start to get the idea. Watch out for replacement, watch out for non-replacement when they don't put the discs back in, and watch out for just slight subtleties in the question. There'll be a few in the examples I'm going to give you to have a look at. So just the last one, this should be a shorter video. So in order to start a course, Bay has to pass a test. He is allowed only 2 attempts to pass the test. The probability that he will pass the test at the first attempt is 2/5. So first attempt, 2/5. That means chance of failing, because either he passes or fails. They must add up to 1, so this must be 3/5. So I can fill them in. If he fails at his first attempt, the probability he'll pass on his second attempt is 3/4. So his probability to pass goes up. He gets better the second time round. But we're going to have pass, and we're going to have fail. So the probability he'll pass at the second attempt is 3/4, which means fail must be 1/4. Now normally we would have a branch here as well, pass and fail. But if you think about the context of this question, if he passes at the first attempt, he's not going to take the test again. If you pass your maths GCSE, you don't take it again. If you get a 9 first time around, which hopefully you will do, then you're not going to sit it again just for fun and get another 9, are you? Well, maybe you will because you love maths, but maybe not. So if you pass the first attempt, there won't be a second attempt because there's no need to try again. So sometimes the context of the question might narrow down the tree diagram or narrow down your options a little bit for you. So again, this is the whole idea of just getting used to slightly different worded questions or slightly different setups, and not letting it throw you. Just think logically about what would happen and you should be fine. So that's our completed tree diagram. And we've got one follow-up question. Calculate the probability that Bay will be allowed to start the course. So we can start the course if he passes the test. So we've got to think about what ways can he pass the test. Well, the ways of this happening either is he passes. The probability of that is simply 2/5. That's the first route. If he passes, he can start the test. So 2/5 from the start. Okay, if he does that first off, doesn't need a second attempt, he can start the test. The other route he can have to start it is if he fails first and then passes. So fail first is 3/5 chance. So now we're going fail first, then pass. So we're multiplying along, always multiply along the branches, times 3/4. And we get 9/20. And both routes means that he'll be able to start the course, because to start the course, all he has to do is pass the test on the first attempt or pass it after failing once. They're the 2 routes to get there. So if we add those 2 together, you've got your calculators. This is 8/20. So this is 17/20. So he's quite likely to start the test. 17/20 is 85%, isn't it? Another little route, just because this video is quite short, because that's it. That's the question done. To think about, to start the course, there's another way that could happen. You could say, well, this is the chance of him not start, 1 minus the probability of him not starting. If you don't understand this little bit, don't worry, you can always do it the first way. Because either he starts the course or he doesn't start the course. So therefore, those probabilities must add up to 1. Just like pass or fail, they're the 2 options, they must add up to 1. So if I work out the probability of him not starting, and the only way he can not start the course is the same as that's failing and then failing again. So 3/5 times 1/4, which is 3/20. So that's the probability of not starting, and therefore the probability of him starting must be 1 minus that, and we still get the same, 17/20. So if you're clever, you can think about 1 minus probabilities as well. But if you're happy just thinking about all the different ways I can start the course, either passing or failing then passing, then adding all those options together at the very end, then that's absolutely fine. So hopefully after watching all these videos, you've got a good idea of probabilities, simple probability questions where it's like 1 spin of a spinner or 1 attempt or something. And then now you've also got ones where you've got 2 independent events, a first attempt, a second attempt, or pulling a disc out of a bag, recording its colour, and then pulling another disc out. And then you've got the whole idea of replacing the disc or not replacing the disc and how that affects the probabilities. We've got to take that into account. And then there are other questions like this one we've just looked at where It's just a little bit different. Context is a bit different, but the whole idea is the same. Always draw a tree diagram if that helps, but you can think about these questions as a tree diagram, but without having to kind of draw it. So there's some exercises for you to have a go, which I'll attach with this task. Use all the videos and everything you've all the knowledge you've acquired from watching these videos and taking all the notes to help answer those questions. And if you don't quite get it first time, keep persevering. Goodbye.